We will talk today about the different motors technologies available and the electric engineering artwork behind that. And we will split this topic in short 6 videos. At the end of the day, it is what it is. But is it really good technology behind motors? The technology is based on the power supply available, so you have AC motors and DC motors. Talking about AC motors, you have two types, synchronous and induction motors. Synchronous have rotor rotational synchronized with the frequency of the supply, and the speed remain constant under varying loads. They are normally used on high-precision positioning devices like robots and instrumentation. Inductions are more common. These motors use electromagnetic induction for changing the energy from electric to mechanical, and you can find two types, single phase and three phases. Single phase are not self-starting, which are used mainly for smaller loads and are the less expensive one. There are four types. The difference is based on how the motor starts the movement, and the type of motor speaks for itself. The first one is resistance torques. Blowers is one of its applications. The second one is capacitor torque, which has high inertia and loads. Pump and actuators are commonly application. The next one is capacitor torque and run. Compressors are a good example. The last one is shade pole, which is self-starting due to the copper ring, but it's run only in one direction. Fans is the best example. Now, three phases are self-starting and widely used in industrial and commercial application. There are two types, squirrel cage and wound rotors. A squirrel cage motor has a cylinder which has laminated slot as a conductor. Every slot consists of conductive material. Those motors are commonly used to manufacture actuator. Now, the wound rotors is like a squirrel cage, but the rotor within is placed inside the slots and are linked with the exterior resistor by the slip ring, which allow varying the value of the resistance and vary the torque. These kind of motor are used in applications that require high torque, like cranes and elevators. Talking about DC motor, you have two types, brush and brushless DC motors. Brush motors are more traditional and their control system is relatively simple. There are two types of brush DC motors, permanent magnet and wound. Permanent magnet have a permanent magnet and excellent starting torque with good speed regulation, but they have low horsepower capability. Robotics and actuators with low power requirement is the common application. Brush wounds, their magnetic field are generated by a wound, and there are three types of brush wounds. Their differences are based on how the magnetic field is generated. The first one is series type, where the field is connected in series with the armature. It produces huge starting torque and non-constant speed. Leaf is a good example. The second one, shunt type, where the field is connected in parallel with the armature. And there are two versions, separately excited and common source. A speed control is available on separately excited motors. Vacuum cleaner is a simple example. The last type is compound type, which is a mix of both types mentioned before. It provides better starting torque and speed regulation. These motors are used inside a circular source. Now, brushless motors. They take the permanent magnetic field usually housed inside brush motor saddle and place it around the rotor in the form of actual magnets. This technology is a long life, low maintenance and high efficiency, but they have higher initial costs and more complicated controllers. There are two types, standard BLDC and stepper motors. The standard BLDCs have a motor controller which uses Hall-effect sensor to detect the rotor position, and it allows to regulate the speed. A BLDC will usually have few steps, like 4-step revolution. Some compressor and some actuators use this technology. Stepper motors have all features of the standard ones, but you can control which pole the rotor jumps, effectively allowing for precise stepwise rotational movement and high repeatability. Typically, stepper motors have 40 plus poles, and they usually don't have rotational sensor, but they have simple drivers with some limitation on speed and torque. Printers are a good example of this kind of motor. Now that we understand all type of motors technologies available, we can confirm that some of them are very useful with electric actuation products. So why is all of this useful? This example will open your mind. The power supply available could not be linked with the type of motor to be used inside the actuator. The electronics inside the actuator can fix it. Emerson can use most of the motor type features disregarding the power supply available. For example, the XT3000 technology allows one-phase input power supply, but this actuator can have three-phase motors. Now, the one-phase actuator can have the power factor and efficiency features of the three-phase motor. So we have different type of valve because we have different kind of application and fluid to control. We also have different type of process control. Now, bearing that in mind, all the technologies mentioned before, each designer can have actuator motor preference between AC and DC and acknowledging power supply available at the side. So, taking all of this into consideration, you can see here all Emerson Bettis Electric Actuation Portfolio divided by the main type of motor used in the actuation industry. 3 phases, DC brush permanent magnet, a standard brushless DC motor, and stepper motors. As you can see here, Emerson Bettis can offer a solution with any kind of motor. However, the XT3000 is that product with most of the capabilities to do any kind of automation, taking into consideration torque range, reliability, diagnostic, and safety. In our next session, I will explain to you the importance of the efficiency and how is it important for actuators and valve. So I don't have anything more to say than thank you for your time and have a wonderful day.